assignments.
And all the weird people just dab.
Just a show, bro. Watching I love it. It's funny as hell.
I just keep looking at the date.
So.
How did you feel about the nail? Towards the end.
About what?
How did you feel about the nail?
Oh,
Do you remember that?
yeah.
Completely. It's like you hated it.
Please close your laptops. You should have already done your homework. If you haven't, then you can do it later on your time, please. On your time, please. Oh, speaking of. A lot of you guys are trying to pull that. Your homework, when you do it on paper, because you guys are doing it on paper, right? You're not just spitting answers out. Please turn in your homework, top shelf, period 1, before class starts. So first thing, come in, drop in your homework, and then have a seat.
What happens if I really don't use paper?
My work's literally.
Well, then that would make sense. I would know. But there's sometimes you have to write something down.
Was this one of the
Can we
I'm not
start
sure
that like
guessing.
tomorrow?
Huh?
I guessed on a lot of last night.
I guess a lot of all of my homework actually.
Can I see my work?
Look at him. He's like, I
I
don't
promise
know.
I
Start
did
that
it.
tomorrow.
I
Like,
just
don't do it today. Like,
Right.
start tomorrow.
I sit down
Yeah.
and try to.
Yeah, not tonight. I just told you,
Yes.
so I can't do that.
Okay.
That's not cool.
Very,
So
Wait.
that's what I'm expecting is that you turn in your paperwork.
Is that for grade 2?
No, if you want your grade, then I need to see paper.
Oh.
What's up?
Right. With our quiz, are we gonna send it up there too? Or practice?
Yeah. All work needs to get turned in so I can take it.
Wait, even really bad. Even whenever you're going.
Starting now, yeah.
Thanks for going, Wes.
Okay. All right, so let's take a look at this problem. The orbit of planet A has a mean distance of 3.1. Can I make that a little big for you guys? 3.1 times 10 to the 7th miles, while the orbit of planet B has a mean distance of 7.1 times 10 to the 7th miles. How long would it take the spacecraft traveling at 1.000, that's ridiculous, times 10 to the 3rd miles per hour to travel from orbit of planet A to the orbit of planet B? So, you want to get from A to B, you're just traveling the distance, aren't you? So the question is, what's the distance that you're traveling? Well, which of these two planets is further away? This is 3.1 times 10 to the 7th, and the other one has a 7.1 times 10 to the 7th distance away. Subtract the two, right? So, if I do 7.1, now they both have the same power of 10, so I can just do what's 7.1 minus 3.1? 4. So that is 4 times 10 to the 7th, right? That's the distance. Now, if you guys think about the formula, distance equals rate time, correct? So, distance equals rate time. I'm looking for, what am I looking for? How long? How long is time, isn't it? How long would it take? So if I divide this by r, that means the time would be the distance, which we kind of have. I can't see it very well. 4 times 10 to the 7th. So that's the distance I have to travel. I'm just going to divide it by how fast I'm traveling, which happens to be the rate of 1 times 10 to the 3rd. Okay? So what's 4 divided by 1? 4.
Would it be just 10 times 10 to the 7th, or to the 4th?
Yes. So 4 divided by 1 is 4 times 10 to the, now this is going to get moved up, which becomes 10 to the negative 3. So what's 7 minus 3?
Not 5.
Not 5. 4. So there you go. I did it twice too.
He checked his work 3 times.
I couldn't get 7 minus 3 for some reason.
Why didn't you just count it on your fingers or use a calculator?
You know what? I didn't want to look like I was using it. I tried to do it in my head, but it made sense to me.
That's simplified?
Yeah, that's it. Yeah, because this is just a 4. Now you can write if you want. You can write 4.00000000000.
You don't have to do that.
Type
Right?
no. Just me being dumb. I want to see what it says though.
Would they even take that?
I want to see what it says. Yeah, 4 point.
Oh my. Okay.
Times
Funny.
10. You guys know how to do the power, right? You can use the control, the little caret, or you can just push that button. Times 10 to the, what was it? 5? 4. Woo!
I really took that. So much.
I think it's funny. I love it. That's great stuff. Forgive me for enjoying math. Okay.
You're opposite of us.
Math is fun. Math is fun. You just gotta know the rules, right? You just gotta know the rules. All right. So there's no other questions then. You guys are good to go. All right. Let's get started with the next part. 5-point deuce. You're early for tomorrow.
Oh, I have McDonald's.
What is it?
About like C2 people.
Okay.
So,
That bag needs to be in your backpack.
that's fine. I'll put it in my bag. He asked if you wanted to make muffin, bro.
You want one? What if we bring you food and we're late with food,
Are you gonna-
but we bring you food? Oh,
Um,
they don't get done with anything.
we never get that.
It's okay. I'll fix it.
Slideshow. Alright, cool. So chapter 5.2.
Oh my God, what is up with
Adding and subtracting polynomials. 1. Know the basic definition for polynomials. The definition is pretty nasty, but it's not a difficult one. Okay? Be able to find the degree of a polynomial and then add, subtract polynomials. Everyone knows how to add and subtract, right? So then you should be, hey, some of us don't. Callie putting me on blast. Some of us don't. But you guys do. I don't. But you guys do. So you guys should be okay with this. I might struggle a little because I don't know my pluses and my minuses. Thanks, Callie. On the recording. Alright, so let's talk about the basic definition of a polynomial. Okay? Let's start with the word term. A term is a number, a variable, or the product of a quotient of a number and one or more variables raised to a power. So, if you take a look at all these are all just terms. So, for example, 4x, if I've got 1/2 m to the 5th, which is also the same as that because 1 times m to the 5th is just m to the 5th. Here is another term. Here is another example. All of those are just terms. Okay? If you take a bunch of these terms and you put them together, you create things called polynomials. Okay? Now, it's kind of weird because if I take one of them alone, just one, that's called a monomial. It's called a monomial. If it's just one term, it's called a monomial. If you put two terms together, it's called a binomial. And you put 3 of them together, you get a trinomial. If you put 4 of them together, you're just going to default to something called polynomial. Poly means many. Okay, I think you guys have heard the word poly before, or what is it, prefix poly? It just means many. Okay, and of course, nomial does mean term. I forget if it's Greek or Latin or something. One of those languages that we stole everything from. So polynomial just means many, so it just means you have many terms. Okay, so you have monomial, which means one term, binomial, which means 2, trinomial, which means 3, and then from there you're just going to go polynomial. Okay. Something else, if you don't want to, you can also say n-nomial, where n is the number. So if you have like 9 terms, you can just say, to be specific, you can say 9-nomial or omial. Maybe it'll show up on the slides in a little bit, okay? Dash, sorry, I put a little apostrophe, didn't I? Another apostrophe? Yeah. Okay. The numbers, if you have a number, for example, if you take a look at the 4x. The 4x has a variable, right? And it also has a number. The number is called a numerical coefficient, but we just say coefficient. Okay? This has a coefficient. That has a coefficient of -7. Here's a coefficient of 6. This is a coefficient of, 5/3, I guess you could call that. And then 9. Does 9 have a coefficient? It does not. It's just a number. It's 9. Okay? Okay. Algebraic expression. When you have an algebraic expression, it just means you threw letters in there. Okay? We've been mathing since elementary school with just numbers, right? Those were numerical expressions. If all you see there are numbers, numerical expressions. Once you start throwing the alphabet in, it becomes something called an algebraic expression. That make sense? Cool beans. Polynomial is a term or infinite sum of terms in which all variables have whole number exponents and no variables appear in the denominator. So here's some examples. Okay, these are all polynomials up at the top. These at the bottom are not polynomials. This is not a polynomial because if I take x to the negative 1 is not, you would have to make it positive, right? Which would put x in the denominator, and that violates the rule of polynomial. Okay? Same thing with this one. Here, if you take the square root of x, you have to find something funky there. It's not just a whole number. And of course at the end, 1 over x. Anybody getting these down? I'll wait a little bit. Or you guys are good?
The decimal, the polynomial, or?
Have whole number exponents. Yeah, so you can have a decimal. You can have a decimal as a coefficient. Yes. All right, here we go. In order to put a polynomial in standard form, you have to put them in this descending powers. That means from the highest power to the lowest power. This is x to the 5th power. This is x to the 2nd power. This is x to the 1st power. So they have to go from highest power down to the lowest power. That is the standard form for writing a polynomial. And you guys remember this stuff, right? Cool, so I won't spend too much time. Maybe something you don't remember? X to the 7th, x to the 3rd, y to the 4th. Which of those two terms has the highest power?
Y.
What's the degree of this term? 7. What about the degree of this term? It's also 7. Okay? I know that the variables are not the same, but we're not looking at combining the two. We're just looking at the degree of that term. The degree happens to be 3 for this one and 4 for that one, which makes 7. So as far as degree is concerned, they're identical. Okay? So I'll throw that in. Clap on. Clap on. Okay, so if we were going to write this in order, what would we start with? Z to the 5th. Then? Negative 3z to the 4th. 2z to the 3rd. And then finally, minus 6z. Okay. And of course, here's that terminology again. Trinomial, binomial, monomial. And if it's more than that, we call them Is there a problem, sir? Do you happen to know this already? Just lost 2 cool points, man. Find the degree of the polynomial. Hey, there's no polynomial. Oh, that's the objective. Find the degree of the polynomial. We want to find the degree of the term first, because once you find the degree of the highest term, then that becomes the degree of the polynomial. For example, in this case, we take a look at this term here, 2x to the 3rd. The degree is 3. Here the degree is 4. Here the degree is 1. Okay, so when we're looking for the degree of a polynomial, that means when we've got a bunch of them together, we're looking for the one term that has the highest degree, because then that would become the degree of the polynomial. In this case, which term has the highest degree?
2.
This one does. So the polynomial, the degree of the polynomial also becomes 2. If you take a look at the second example, this is the highest degree term. That becomes the degree of the polynomial. Because that's 1, then it's just 1. This is actually negative 2 times x to the 0, which is something we don't have to really write down. But if you're asking for the degree of this, you would say 0. Okay? And then here the degree of this term, like I said earlier, you have a 2 and you have a 5, so that would make the degree 7. Okay, questions there? Adding and subtracting now. Okay, when we add and subtract, first going back to combining the like terms, let's just start with A. I see that this one and this one are like terms, correct? So that would simplify to 3z to the 4th. And then these two are like terms, so that would become negative 6x to the 4th. Okay? So do I need to do anything like that? Any combining like terms for anybody else? You guys are good? Okay. Okay, moving on. Here we go. Let's start adding them. When you add them up, how many people just go right across and match them up? Okay. Do you guys remember the old school way we used to add things? If I told you to take 237 and add 56 to that, well, what did you do? You'd stack them, right? Now, did you stack them 237? Did you stack them like that? Why not? What's wrong with that? Why is it in the wrong place? Huh?
Because it should be 5, 6.
It's not in the ones place.
So there's a specific way of adding them up because the place value matters, doesn't it? Okay. So we know that that's 56, which means the 5s need to go with the tens column and the 6 needs to go with the digits column. And then we went ahead and we did our addition stuff, right? So what we were doing is we were lining up the like terms. These are ones, these are tens, these are hundreds, correct? All right, same idea when you're going to add or subtract polynomials. So if we're going to have negative 5p to the third plus 6p to the second, I want to make sure that if I am going to add them, I also line up the same positions. So I've got 8p to the third minus 12p to the second, and then I'm going to add them up according to their place value. So if I've got 6p to the second minus 12p to the second, that's going to give me negative 6p to the second. And then I've got negative 5p to the third plus 8p to the third would give me 3p to the third. And there you go. Please believe me, if you start doing that now, it's going to help you later on when we start into the multiplication and the long division. Okay, please start lining them up right now. Get in the habit of doing that. It's going to be easier for you. Especially because I used to do like you guys. I would just be like, line them up and all that stuff, and I'd always forget one. I end up adding it twice or something. Because you know that those things get longer than that, right? Chop. Okay. Boom, we're done. Is that the same problem?
No.
Oh, that's just saying exactly what I just said earlier. Cool, I like that. All right, cool. Subtraction, it's going to work the same way. One thing that I do like to do myself, though, plus p to the third, everybody prefers to add before you subtract, right? Okay, so I know that this negative here in the front is going to change the signs of all of these terms on this side, isn't it? So instead of writing a positive 3p to the fourth, I'm going to go ahead and make that a negative 3p to the fourth and a negative 5p to the third. It's a horrible thing. Negative 5p to the third and then a negative 2. Okay, so I took care of the distribution first. That way all I have to do is combine them and not worry about whether I subtracted correctly or not. Okay? So that's going to give me a positive 3, a negative 4p to the third, and a negative 2p, to the fourth. Questions there?
Whenever there is a parentheses, are they gonna be like switched up? Like say like P to the fourth and P to the third? Could they switch?
Change them? Yeah.
So what would you do? You just
Put them in order first.
Okay.
Put them in order. Alright, cool. Moving on from this one.
I don't know. I don't know.
Oh, that's it. We're done.
It's just.
Do you have one more?